In the unforgiving calculus of military aviation, physics is the only true arbiter. Every design choice, the sweep of a blade, the composition of an alloy, the logic encoded in a flight control computer, is a wager made against gravity, air density, and the lethal physics of incoming ordnance. Here, every bolt and every panel can indeed determine the outcome of a battle, and a machine that fails to respect these immutable laws is destined for the scrap heap before it ever leaves the drawing board. The Harbin Z-20 is a machine born from this harsh reality, a direct and emphatic answer to a problem that haunted the People's Liberation Army, PLA, for decades: the tyranny of high-altitude terrain. Across the vast oxygen-starved expanses of the Tibetan Plateau and the mountainous western frontiers, the PLA's vertical lift capability was consistently found wanting, a critical operational deficiency that limited its ability to rapidly project forests, resupply remote garrisons, and conduct effective search and rescue operations. This strategic vulnerability was starkly illuminated in the 1980s with the acquisition of 24 Sikorsky S-70C-2s, the civilian designation for the formidable UH-60 Black Hawk. These American-built machines performed with an unnerving effortlessness in the thin air where Chinese and Russian-designed helicopters struggled, a transformative capability that their existing fleet could not reliably replicate. The fallout from the 1989 Tiananmen Square protests and the subsequent U.S. and EU arms embargo, however, abruptly severed this lifeline, leaving the PLA with a small, aging fleet of high performers and no prospect of acquiring more. This geopolitical event crystallized a strategic imperative. China needed its own Black Hawk. The so-called 10-ton helicopter project, initiated in 2006 and given a renewed sense of urgency by the operational lessons of the 2008 Sichuan earthquake, which highlighted the immense value of such platforms in disaster relief, was the direct result. The machine that emerged with its first flight on December 23, 2013, was therefore not born of a simple desire to copy, but from a pressing, geography-specific need for a proven solution to a known problem. At first glance, the Airframe is an exercise in profound flattery, bearing an unmistakable resemblance to the S-70 UH-60 lineage in its overall layout, dimensions, approximately 20 meters in length and 5.3 meters in height, and a maximum takeoff weight squarely in the 10-ton class. Yet to dismiss it as a mere clone is to overlook the deliberate and significant engineering deviations that mark it as a distinct second-generation design. The fuselage is visibly more voluminous, particularly in the rear cabin area, and connects to the tail boom via a more angular, chiseled joint frame. These are not aesthetic choices. They are calculated design modifications intended to increase internal cabin capacity for troops and equipment and to generate greater aerodynamic lift, directly addressing perceived limitations in the original Black Hawk design after decades of PLA operational experience. The cockpit glazing further illustrates this philosophy of iterative improvement, employing a two-piece windscreen that offers a wider, less obstructed field of view for the pilots compared to the Black Hawk's traditional three-piece design. While specific metallurgical and composite layup details remain closely guarded, the construction evidently employs a modern blend of materials. Advanced fiber-reinforced composites are certainly used for the main rotor blades and likely in non-load-bearing fuselage panels and fairings to minimize weight and enhance ballistic tolerance, while a conventional aluminum alloy structure forms the core airframe for manufacturability and durability. The most critical physical deviation, however, is the main rotor system. The Z-20 employs a 5-bladed main rotor, a fundamental departure from the 4-bladed system on all standard Black Hawk variants. This additional blade has profound aerodynamic implications. For a given rotor diameter of approximately 16 meters, it increases the total blade surface area, allowing it to generate significantly more lift, a crucial advantage in the thin air of high-altitude environments. It also distributes aerodynamic loads more evenly, resulting in a smoother flight and potentially a reduced acoustic signature. This design choice is a direct engineering solution for the primary problem the helicopter was built to solve. This system is further enhanced by cutting-edge anti-icing and de-icing technology integrated into the rotor blades, a critical feature for all-weather operations in the freezing conditions common to its intended operational theaters, and a capability China claims makes it only the fourth nation to have mastered. Beneath this evolved airframe lies the machine's most critical and scrutinized indigenous component, a pair of domestic Z-20 turboshaft engines. On paper, these power plants are formidable, each rated to produce a continuous output of around 1,600 kilobars, 2,100 shp, with an emergency thrust of up to 2,000 kilobars, 2,700 shp. This places the Z-20's power-to-weight ratio, at least in theory, slightly ahead of the modern UH-60M, which is equipped with General Electric T700 701D engines producing around 1,500 kilowatts each. This power advantage is the linchpin of the entire Z-20 design philosophy, engineered to enable operations with a meaningful payload of 12-15 troops or 1,500 kg of internal cargo at altitudes exceeding 4,000 meters. The resulting performance envelope is impressive, with a stated maximum speed of 360 km/h, a service ceiling of 6,000 meters, 20,000 ft, and a combat range of 560 kilometers. However, the world of military hardware is littered with machines that look impressive on paper but require a ritual dance to start up in the cold. A curious paradox has emerged that casts a shadow over these specifications. Despite being heavily marketed as the PLA's premier high-altitude platform, the Z-20 was conspicuously absent from a major real-world disaster relief operation in Tibet, where the older Russian-designed Mi-171 was deployed instead. This suggests that while the WZ-10 engine may be capable of high peak power, it may still be wrestling with the teething issues common to new high-performance turboshaft programs, such as reliability, maintainability, or performance degradation under sustained high-load conditions in thin air. Mastering advanced metallurgy and thermal management for turbine blades is a notoriously difficult art, and this operational absence hints that the Z-20's heart may not yet be as robust as its airframe, forcing field commanders to trust a less advanced but thoroughly proven workhorse when lives are on the line. If the engine represents a potential vulnerability, the helicopter's digital nervous system is its greatest strength. The Z-20 is China's first helicopter to incorporate a full fly-by-wire FBW flight control system, a generational leap that sets it apart from its American conceptual predecessor. By replacing a heavy and complex network of mechanical rods, bell cranks, and hydraulic lines with electronic signals processed by flight control computers, the FBW system reduces overall weight, simplifies maintenance, and significantly enhances maneuverability and stability, especially in adverse conditions. This was a deliberate leapfrog strategy, adopting a technology that, while tested, has not been implemented across the standard-issue UH-60M fleet, which still relies on a digital automatic flight control system with mechanical backups. This digital architecture is the foundation for the Z-20's future, providing the necessary backbone for the eventual integration of optionally piloted modes or even full autonomy for certain mission profiles. The crew interfaces with this system through a modern glass cockpit, featuring at least 5 large multifunction displays that integrate all flight, navigation, engine, and sensor data into a coherent tactical picture. This advanced avionics suite is protected by a comprehensive defensive aid system, including radar and laser warning receivers, a missile approach warning system, and 4 chaff and flare dispensers positioned to provide 360-degree coverage, ensuring a high degree of survivability on the contemporary battlefield. This robust and technologically advanced platform provides the ideal foundation for specialized variants, the most significant of which is the Z-20T heavy assault model, sometimes referred to as the Assault Eagle. This variant transforms the utility transport into a potent fire support and troop insertion platform through the addition of removable stub wings, analogous to the Black Hawk's External Stores Support System, ESSS. These wings feature multiple hardpoints, typically 2 per side, capable of carrying a diverse and lethal array of ordnance. Precision strike capability is enabled by a chin or nose-mounted electro-optical infrared (EO/IR) sensor turret, which provides targeting data for laser-guided munitions and allows for effective operation at night and in low visibility conditions. The Z-20T's arsenal is versatile, reflecting a multi-mission design philosophy. For anti-armor roles, it can be armed with laser-guided missiles such as the AKD-9 and AKD-10. For engaging targets without a direct line of sight, it can carry NLOS missiles like the CM502KG. Area suppression is provided by large-caliber rocket pods, with 19 tube launchers having been observed, representing a significant increase in firepower over smaller pods. For self-defense against aerial threats, it can be equipped with TY-90 air-to-air missiles. Provisions for door-mounted machine guns and podded autocannons round out its capabilities. It is crucial to understand the Z-20T's doctrinal niche. It is not a dedicated attack helicopter designed to hunt tanks in the same vein as the Z-10 or the forthcoming Z-21. Rather, it is a multi-role assault transport whose primary mission is to deliver a squad of 12-15 fully equipped soldiers into a hot landing zone and then provide immediate, organic, and overwhelming fire support. This makes it an ideal asset for the PLA's air assault brigades and special operations forces, a direct counterpart to the specialized American MH-60L Direct Action Penetrator, DAP. The Z-20 is merely one branch of a rapidly growing family tree, illustrating a platform-centric development model that leverages a mature core design to fill multiple roles. Naval variants, designated Z-20J for assault and transport and Z-20F for anti-submarine warfare, ASW, are being fielded to plug a critical vulnerability in the plan's blue water naval groups, providing a capable helicopter small enough to operate from destroyers and frigates, but large enough to carry a full suite of dipping sonar, sonobuoys, and lightweight torpedoes. Other versions include the Z-20S for search and rescue and the Z-20K for airborne corps operations. The future trajectory also includes persistent rumors and concept models of a low observable or stealth variant. The development of such a machine was likely given an unexpected and invaluable boost by the convenient availability of a crashed American stealth-modified Black Hawk's tail section in Abbottabad, Pakistan in 2011, which almost certainly provided Chinese engineers with a priceless hands-on education in radar-absorbent composite materials, faceted shaping, and advanced acoustic suppression techniques. The ultimate validation of the Z-20's core design, however, is the emergence of the Z-21 heavy attack helicopter. This new machine explicitly leverages the Z-20's proven dynamic components, its powerful engines, transmission, and 5-bladed rotor system, but places them within a new, slim, tandem-seat attack fuselage, accelerating the development of a top-tier capability without the risk and expense of starting from scratch. In conclusion, the Harbin Z-20T, while bearing an undeniable and pragmatically adopted resemblance to the UH-60 Black Hawk, is far from a simple carbon copy. It is a purpose-built evolution, intelligently adapted to specific PLA requirements for high-altitude performance and internal capacity, and integrated with next-generation technologies like a full fly-by-wire control system that its American counterpart lacks in its standard fleet configuration. The platform represents a significant milestone for China's aerospace and defense industry, demonstrating a mature ability to not only replicate a proven design, but to thoughtfully revise and improve upon it based on decades of operational experience. While legitimate questions about the long-term reliability of its indigenous power plant will likely persist until the type has a more extensive service record, the overall Z-20 platform is a versatile, survivable, and formidable addition to the PLA's arsenal. It is an echo of a Western design, but one that is now speaking with its own distinctly Chinese voice, articulating a clear and ambitious vision for the future of PLA aviation across land, sea, and air. While the Z-20's genesis was rooted in the high-altitude demands of the PLA's land-based forces, its ultimate strategic importance may well be defined by its adaptation to the maritime domain. The rapid and unprecedented expansion of the People's Liberation Army Navy plan from a coastal defense force into a true blue water navy has created a parallel and equally urgent set of operational requirements. For decades, the planned surface combatants were hamstrung by a critical deficiency in organic air assets. The fleet relied on the Harbin Z-20, a license-built version of the French Dauphin, and a limited number of imported Russian Kamov Ka-28s. The Z-20, while versatile, is fundamentally a light helicopter limited in range, payload, and endurance, rendering it inadequate for sustained anti-submarine warfare, ASW, or meaningful troop transport. The larger Ka-28, with its distinctive coaxial rotor system, offered greater payload and specialized ASW capabilities, but was available in insufficient numbers, suffered from logistical and maintenance challenges inherent to foreign-sourced equipment, and its bulky design limited its compatibility with the plan's growing fleet of smaller frigates and destroyers. This helicopter gap represented a glaring vulnerability. A fleet of advanced Type 052D destroyers and Type 054A frigates without a correspondingly capable shipborne helicopter is a fleet with a severely constrained operational reach and a gaping hole in its anti-submarine defenses. The navalized variants of the Z-20, colloquially dubbed the Sea Eagle, are the plan's definitive answer to this vulnerability. Developed in two primary configurations, the Z-20F for Fankian, anti-submarine, and the Z-20J for Jianting, shipborne, these helicopters represent a quantum leap in capability. Both variants incorporate essential maritime modifications, a robust automatic blade and tail-folding mechanism for compact storage in shipboard hangars, a modified landing gear with a smaller wheelbase for enhanced stability on a pitching flight deck, and extensive anti-corrosion treatments to withstand the harsh saltwater environment. The Z-20J serves as the general-purpose utility and assault workhorse. Its mission set is broad, encompassing vertical replenishment, VERTREP, maritime search and rescue, SAR, naval special warfare, Nesebala with force insertion and extraction, and anti-surface warfare, ASUW, against small craft. Its larger cabin and greater payload capacity compared to the Z-9 allow it to transport a fully equipped boarding party or a rescued aircrew with far greater efficiency. It is the Z-20F, however, that addresses the most profound strategic weakness. This dedicated ASW platform is packed with a suite of specialized sensors and weaponry that transforms its host vessel into a potent submarine hunter. A large chin-mounted surface search radar housed in a prominent radome beneath the cockpit provides 360-degree coverage for detecting low observable targets like periscopes. For acoustic detection, it carries a sophisticated dipping sonar system, allowing it to actively ping for submerged contacts while hovering. This is supplemented by a rack of sonobuoys, which can be deployed to create a wide-area passive listening network. A distinctive magnetic anomaly detector, MADBOOM, is often seen extending from the rear of the fuselage, designed to detect the metallic mass of a submarine hull. This multi-layered sensor package allows the Z-20F to prosecute a submarine contact using a variety of methods, dramatically increasing the probability of detection and engagement. To complete its hunter-killer role, the Z-20F is equipped with under-fuselage pylons capable of carrying up to 4 lightweight torpedoes, such as the U-7, or anti-ship missiles for engaging surface threats. The operational implications of the Z-20FJ's widespread deployment are transformative. For the first time, the plan's carrier strike groups and surface action groups can establish a credible, multi-layered, and domestically sustained ASW screen. A destroyer-embarked Z-20F can operate as an extension of the ship's own sensors, flying out hundreds of kilometers to sanitize a shipping lane, investigate a potential contact, or protect an amphibious task force. This capability is absolutely essential for any Navy aspiring to project power far from its home shores, especially in contested waters where the submarine threat is preeminent. Furthermore, the Z-20J's role aboard the plan's new Type 075 amphibious assault ships is equally critical. It provides the vertical lift capacity needed to execute the vertical envelopment doctrine, inserting troops and supplies behind enemy beach defenses in a manner directly analogous to the U.S. Marine Corps' use of the MH-60S Seahawk. The Sea Eagle is therefore more than just a new piece of hardware. It is a critical enabler, the final puzzle piece that allows the plan's modern surface fleet to realize its full combat potential and project Chinese naval power with a confidence and capability that was, until now, simply out of reach.